Hello, my fellow learners. We are now here in the next discussion that we have that talks about the Module 2 of the Quarter 1 for the Grade 9 Dep Ed under the Dep Ed or the Department of Education learners. That is all about nature of roots of a quadratic equation. Hope you enjoy it. Hello, my fellow learners. I am here again to discuss with you the relationship between the coefficient and the roots of quadratic equations. This is the module 2 of the grade 9 math. So, hope you enjoy this. The concern of this is knowing the product and the roots, the sum and the product of the certain roots of the quadratic equation given by this formula: ax squared plus bx plus c is equal to 0. With the different coefficients or the numerical coefficient of the quadratic term, which is a, linear term, which is b, and the constant term, which is c, without solving the roots. As far as we know, as far as we understand, based on from the given quadratic formula, we have here x is just the same as negative b plus minus the square root of b squared minus 4ac all over 2a. As then, we know the fact that the first root that we have represented by x sub 1 is just the same as the negative b plus the square root of b squared minus 4ac all over 2a. Whereas the second root of the quadratic equation given by the negative value, negative b minus the negative minus the square root of b squared minus 4ac all over 2a. So the two given x sub 1 and x sub 2 are the roots of our quadratic equation. So let's now have this. So since we have here given the certain roots that we have, let's say x sub 1 and x sub 2, and if we're going to add them both, we come up with negative b over a. And if we're going to have the product of the two roots represented by x sub 1 and x sub 2, we now have the concept of c over a. So from the quadratic equation, ax squared plus bx plus c is equal to 0. So we now have here divide all set of the expression of both sides of the equation divided by a. So we now have here x squared plus b over ax plus c over a is equal to 0. So relatively, if we're going to get the sum based from the linear term now, which is b over a, so the sum of the two given roots is the negative, so the opposite of the numerical here, b over a. So if we have that, the negative b over a, that would be now the sum of the two given roots, referring to this part. Then if we have c over a is now the product of the two given roots that we have. So in short, that we have the constant term, which is represented by c over a, is our product of the two given roots. And then if we have b over ax, then the opposite of b over a, since b over a is our numerical coefficient of the linear term x, so now taking the opposite of that, we have now the sum of the two given roots. In short, given the two given roots, given the two roots that we have, which is x sub 1 and x sub 2, from the quadratic equation ax squared plus bx plus c is equal to 0, provided that our a is not equal to 0, then the sum of the two roots is represented by x sub 1 plus x sub 2, and the product of two roots is x sub 1 times x sub 2. So let's have now here a certain given that we have. Find the sum and product of two given roots for each of the following equations. We now have here The first one is 2x squared plus 8x minus 10 is equal to 0, and the other one is x squared plus 7x minus 18. So for us to work out with this, the first one, which is a, we're going to understand first the value of our ABC, or the numerical values or the numerical coefficients of all terms in the quadratic equation. From the quadratic term down to linear term, the next is the constant term. So in this case, in this given 2x squared plus 8x minus 10 is equal to 0, so we now have here a as 2, b is 8, and c is negative 10. Now, we now have here negative b over a, since we have the sum of the two given roots. So we have negative 8 because b is 8, the opposite of b, which is negative b. So if we have 8, so we now have here negative 8 all over 2, and we now have here negative 4. So this one now is our negative 4 as the answer. While for the product of two given roots, we now have here c over a that we have, so negative 10 over 2, and that is negative 5. So the answer now, the product and the sum of the two given roots is negative 5 and negative 4 respectively. So that is how do we cater with the problem letter A. Now if we are going to proceed for the problem letter B, which is x squared plus 7x minus 18 is equal to 0. So as we able to identify first the value of ABC, so we now have here as, let's say, so we now have here a is 1, b is positive 7, and c is negative 18. So in this case, we now have here negative b over a, so we come up with here as negative 7 over 1. So that is why negative 7 over 1, and we have here negative 7. Okay, that is how we cater with the answer for the problem letter B. That is 11. Rather negative 7, this one here. Then if we're going to have the product, so we now have here negative c over a, and so we have negative 18 all over 2, and that is negative, no, it's 1, by the way, not 2. I stand corrected. Thank you. So this must be 1. So negative 18 divided by 1 is negative 18. This is how we cater with the problem A and B. In determining the quadratic equation given the roots, so we now have here, as far as we know, that we have x sub 1, the first root, and the second root. If we're going to add this one, we come up with negative b over a. And if we have the product, x sub 1 times x sub 2, we now have here c over a. So in this manner, from the given that we have, as we manipulated it, that this one, previously we have here x squared plus bx plus b over ax plus c over a. So in this case, referring to this equation, it means that the given now that we have, the linear term is our sum of the roots, the negative sum of the roots, whereas the product is the constant term of the given quadratic equation. So specifically, we come up with x squared minus the sum of the roots times the x plus the product of the roots is equal to 0. This is now the relationship of our quadratic equation with to its roots that we have. Now, for us to be able to expand further about what is meant by this, so we now have here, we are going to find the given equation. If the certain roots that we have is 4, are 4 and negative 7. So, if we're going to add it up, so we have here negative 3. So, the sum of 4 and negative 7 is negative 3. While its product, which is 4 times negative 7, is equal to negative 28. Then again, as I said, the product would be the constant term, while the sum would be the numerical value of the linear term of our quadratic equation. So from here we have x squared minus negative 3x. Sorry, I have to erase this one that we have because it is not clear to us here. So going back, so again, x squared minus the sum of the roots using this formula here. So we have negative 3 times x plus the product, which is the product of the roots, which is negative 28, is equal to 0. So now, if we're going to simplify further, we come up with x squared double negative, and that is positive 3x. Positive times negative is negative 28x, excuse me. So now have that minus 28 is equal to 0. So the answer for number 1 that we have, if we're given that it's 4 and negative 7, is we have x squared plus 3x minus 28 is equal to 0. So let's proceed now to number 2. Given the roots are given, such as we have here negative 1 and 3 halves, we're going to find the equation that we have. Since we have 2 roots, so it means to say that 1 is our quadratic equation as we go through with that given. Because if we have 2 roots, then maximize minimum, we need to say that one is entitled for a quadratic equation. Now, if we're going to take the sum of the given that we have, so we have here, if we're going to get the sum of negative 1 and 3 halves, so we have here negative 1 and 3 halves, this one here, this one. Then, since we have here fraction, so we get the LCD. The LCD is 2. 2 divided by 1 is 2, times negative 1 is negative 2. Then copy the plus sign. Then copy the 3. So negative 2 plus 3, because since this is a fraction, we could not add if they have different denominator. So all we have to do is to look for the LCD by means of the LCM. Now, negative 2 plus 3 is 1. Then copy the 2. So the product now, the sum now rather, is just 1/2. While the product of the 2 given roots, we have here negative 1 times 3 halves, and we have negative 3 halves as the sum. Now, using the form of the quadratic that we have, if we have the sum, so we now have here x squared minus, because minus is the pattern that we have, sum of the roots is 1/2 times x plus product of the roots, which is negative 3 halves, which is equal to 0. Take note with that. Then after which, we're going to simplify further first about the sign. We now have here x squared minus 2 minus 1/2 x minus 3 halves is equal to 0. Since we have here 2, we now have to multiply both sides of the equation by 2. So we now have here 2 here. So as we distribute this one, we now have here 2 times x squared, then 2 times x squared we have this one here, 2 times negative 1 half x, so we have here, then 2 times negative 3 half, so we have here, this one, then 0 times 2 is, we have that. Now, 2 times x squared is 2x squared, negative 2 times 1 half, so cancel the 2, so we come up with negative x as the remaining value now. Then negative 2 times 3 halves, so cancel it, so negative 3, so we now have which is equal to 0 because 2 times 0 is 0. So we now have the equation which is 2x squared minus x minus 3 is equal to 0 as the result if we have the two roots given, which is 1 half and negative 1 half and a negative 1 rather and 3 halves. So that's it. So hope you enjoy this kind of video lesson with respect to the nature of roots. See you then for the next future lesson for the solving of the quadratic equation. So long for now, and don't forget to subscribe for my YouTube channel, and don't forget to click the notification bell for the future notification of the educational math videos. Okay, and please like and follow my YouTube Facebook page. For now, goodbye.